Hey guys, welcome to Codewile, and today we are back again with a question called Recover Binary Search Tree. It's a medium level question. And before we start the question, if you have not checked the video which we have already uploaded in our channel, do check that out because there are a lot of versatile contents which we are already uploaded. So do check these contents out, and if you like it, do subscribe to our channel. So let's come back to our question. So basically, what they're asking is, they have given a binary root of a binary search tree, where the values of exactly two nodes of tree were swapped by mistake. Recover the tree without changing its structure. Okay. So basically, what they're saying is they have a BST which where two numbers are swapped. So, for example, here you can see this should be in a binary search tree. So, after one left side, you can't get a greater value, that is 3. So, it's obvious that these two are swapped. We have to swap these two. So, we have to swap 3 and 1. So, they have already given us a clue that there are exactly two nodes, right? So, we it's I mean it's bit simple because they are given exactly. They are not given. There are a lot of things, nodes which have been swapped, right? So since there are two nodes swapped, we just have to check which, I mean, uh, in the left side, if the number is, left side consists of the lower value than one or not, right? So if there is anything which in the left side which is greater than the root element, just we know the answer that we have to swap both of it, right? So basically here also you get the same thing, right? You have 3 on the right side. There should every element should be greater than. But if you are going here, you see 2 is less than 3. So you swap these two. So that's the basic fundamental which we are going to use. So what we are doing is, we are just taking a node called, let's take f, which will point to null pointer at the beginning, and which f and s, right? The first and the second one, which has to be swapped. We are going to play around with f and s itself, because f will be the root one and s will be the previous one. The like the pointer which has to be swapped. So we'll have a history sort of a pointer that will be a previous pointer. We'll have a ptr. Cool. Now, the thing is, we know that, the it's in a BST, right? So it will be easy if you're going in a in order traversal. So we use in order traversal. We can use some other also, but this is bit simple, right? Because you know that if you're going in, if you're applying a in order traversal to the BST, it will come in order. What is the order? It will be in the sorted manner. More than the sorted manner, the traversal is bit clear. If you're going through the in order, if you're traveling through in order traversal. So let us name this in order. So root f s and previous, right? So let's solve this in order. So we know that in order what happens. We import the root and again copy this. And we have to take it as a reference because we are going to change its value, right? So we have to take it as a reference, and s, and also previous, right? Cool. So now we know the base condition, that is if root, then return, and in order, we go to left first, and after left you check for the condition if you have anything. So yes, and cool. So now we have to check if previous is true, if there is a previous element, and if root value is less than previous value. That's what we said. Since we know that there are only two elements which are being swapped, so we set a root value and we will have a previous value. So we just check in between those two, right? So if this is true, what we say is we also check if f is also true. This is also important. So if this is true, we say we assign f2 what? What do we assign f2? F2 previous and s2 root, right? So if this is, I mean, after this, what we do, we also say previous equal to root because we have to change the previous pointer to, right? So after this, we will give the other condition that is going to the right. If yes, we right. I guess everything is fine. Oh, so here's the thing. We should also, uh, I mean, we are fetching the elements which are, which are the less than and the greater one. We have to swap those, right? So it will be stored in F and S. So what we do is we just swap F value and S value. That's it. That's pretty much it. So we just return. Let's run this. What's the issue? Oh, expected for what? Line 39, line 22. One void in order. Okay, sorry. Pressure for okay, does work. Let's run this. Yeah, it does work. And yeah. So I hope you got the solution. If you didn't get the solution, do rewind the video and watch it again because it's not that difficult. I mean, you can easily grasp it once you get the, logic. Because it was easy because there was only exactly two nodes, right? That was one of the key main thing which made it a bit simpler, right? So yeah, that is pretty much it from this video. If you like the video, if you like the content, do like the video and to subscribe to our channel for more updates. Thank you.